YUMIN Primary School.
My name is Guo Cheng Guang, also from YUMIN Primary School.
This lesson is Calculus, Chapter 5, Indefinite Integration. And right now, we'll find the antiderivative for this indefinite integration. Firstly, the domain.
The domain, because it's a square, so definitely can be negative. But if it's a 0, it can plus 5, so it can be anything. Except for positive infinity and negative infinity, only 2.
Okay, then.
Because infinity is not a number.
And what else is so special about this?
There is a quadratic.
You mean the denominator is
Yes.
quadratic? And also, don't forget about this coefficient and this constant. But what's more special about this?
Oh, can we factorize?
And the factorize you're talking about, is it like take out a number, or is it become like something x plus or minus something and then times?
The second one.
Okay.
Actually, we can. Except for if it's in real number, we cannot. If it's in complex variable or complex
Numbers?
we can. Except for it's longer.
Okay. But it is more general, okay?
Yes.
So right now for this we have two methods.
First method.
Method 1. What is it called?
The first method is straight away by formula. Okay. And read the question, please.
Okay, and this question is integral dx over 3x squared plus 5.
The first formula that we use is integral dx over x squared plus a squared equals 1 over a tangent inverse bracket x over a plus c.
So now you will
Rationalization.
rationalization.
Yes.
Write it bigger.
The other formula is
and these two formulas. First one, integral dx over x squared plus a squared. That is 1 over a inverse tangent x over a bracket plus c. And the second formula is integral dx over x squared plus 1, which is inverse tangent x plus c.
yes.
And this is actually a special one.
Now we rationalization again, right?
So right now we'll rationalize.
Okay, write down the answer, please. So actually, the second method, you always think of it, complex variable bar. Actually, is factorization.
In complex variables.
Yes.
So this is the first method, right?
Right. Get a quick look before we erase.
Okay, so right now we will continue with the second method.
And definitely, you know it's actually complex variable, complex numbers, all those. But which method? Partial fraction. So the method is called partial fraction in complex variable. And your words are dropping. So the new number, which is I, equals to square root negative 1. So the first step, factorize.
And what do we use? Isn't it a x squared minus a squared?
Yes.
Write it out. Like this. Okay, so like this is it correct?
Yes.
So for this, we'll use partial fractions.
Yes. And
So right now for this, here we have an A. And here we have a B. Like this, is it correct?
Yes.
So how should we find what is A and what is B?
Common denominator, right?
Okay.
So actually after this, we will times this to both of these.
Like this, right?
Yeah.
So what can we have right now? So right now for this, you can have the A squared, A as 0 and B as -1, can?
Okay.
But like that, you actually have a 2 square root 5i, right?
Okay.
Because that A is 1 and B is a -1, and you have that extra, so you need the 2 over the extra, right?
Right.
Remember, A is 1. And B is -1. Like this, is it right?
Right.
Okay, so like this. We have this right now, right?
Yep.
Can we separate?
Yes.
Like this, right?
Okay.
And right now for this, because that here is the square root 3, so you want to square root 3 here, and you also want to square root 3 here, right?
Yep.
So here times here you divide, right?
Right.
And what happens to a constant? And what happens to a constant?
The constant.
You can just add it, right? Because it doesn't affect others.
Yes.
Like this, is it right?
Right.
Okay, so right now for this part still stays here. for this, what do we use?
We use the...
Do you know of any formulas that have something like this?
Ln.
The logarithm, right?
Yes.
And remember, because right now it is in complex variables, so you can use the brackets. Okay, you can use the brackets because that in complex variables, inside the line it can be anything. Okay?
Yes.
Everybody clear?
Because even inside square root also can be a negative. Even though you usually will write it as this, but for complex variable, it's another.
So right now, these two logarithms, they minus, right?
Yes.
So that means they can over, correct?
Yep.
Which actually means that it becomes a fraction, right?
Yes.
Like this is okay?
Okay.
So right now, can we denominator rationalization?
Of course. Because the denominator cannot have a square root.
So what happens to both the numerator and denominator?
Numerator just bracket square, denominator is just a 3x squared plus 5.
Okay, let me write it for you.
Minus 5 minus square root 5. Then normal I.
Like this?
Yes.
Okay, so right now for this, because here is a square, and here is actually a square root square, right? So can we put the two over here?
Of course.
Like this is okay?
Yes.
But actually, we can still continue, right?
Right.
But do you have any ideas how can we continue? Okay, so let me tell you. At this place, this lawn, we can have this. Okay, let's just look the inside. But this I you can write it outside, okay?
Yes.
Do you still remember the Euler's formula?
Yep. E to the power of I theta, which...
But in this case, it's a negative I theta, right?
Yes, so it's cosine theta minus I sine theta.
Like this, is it right?
Right.
But then for this, okay, you have this. So this is actually a cosine. And here, excluding the I is the sign, right?
Right.
Have you ever wondered what the triangle can be like? Like this. And then, here's the cosine, right?
Yep.
Which is adjacent. Okay, and what about
Don't
here?
forget your x.
So here, this is the oval, right? Okay, let's check whether it's correct.
Hypo.
Yes, there's the hypo.
This definitely is a right angle triangle.
What if they never give the hypo?
Of course. Yes.
You can actually use the Pythagoras theorem even if they didn't give, right?
Yep. And this is definitely the right angle triangle.
Yes. So like this is a triangle, right?
Yep.
So next, what can you have? Can you have an example like ln z and then give an example of z, okay? Can you?
Okay. For example, then
Ln z, remember? First is, okay, you can say what is z first. Okay, so it is 3 plus 4i. So ln z, and remember you have that modulus. Modulus.
it's actually also known as magnitude.
Okay, so this ln, that will be the square root. 3 square plus 4 square, right?
Yep.
But remember up here you have times e to the power of I theta. Okay, so actually for this, in this case, you still remember that ln, for example, xy is
Ln xy equals to ln x plus ln y.
like this, right?
Yep.
Okay, so like for example cases of this, you can write it as ln, here's a 5, right?
Yep.
And here is plus ln e to the power of I theta.
Still the same.
Remember, I theta from this power can come out. So this is a 1, right?
Of course.
So this is a 1. So just that the ln 5 plus I theta. But remember, this is just an example, okay?
Okay.
What about our case? What happens to our case? Okay, first, this part square becomes
It becomes 3x squared plus 25. Oh, you mean in this case?
yeah.
Okay, so it will be like that.
So like this is actually a 1, right?
Okay.
Because when you combine them here, it's the same, right? So this is a 1 and a square root 1 is still
A 1.
So right now here you have this and this is a ln
1.
ln 1. So here you can just use brackets, right?
Yep. But you can actually don't write the 1.
Okay, so then after that, plus or minus? This will be a minus, right?
Yeah.
So this is a minus. It is an inverse tangent.
Inverse tangent square root 5 over.
But actually you can use whatever like inverse sine, inverse cosine or whatever, right?
Except for inverse tangent and inverse cotangent.
Oh wait. There's I.
Don't forget the I.
Okay, so for this, it can be like this, right? You can actually use any, like inverse sine, inverse cosine, inverse secant, inverse cosecant, inverse tangent, or inverse cotangent.
But actually, tangent and cotangent
Is the best.
yes, because it's easy.
Okay, so like this, because that here is theta, right? And this is the theta, correct?
Yep.
And this is actually how you can find the theta, right?
Yes.
So right now, what is ln 1? I want to know what is ln 1. What is the base? Okay, first tell me, what is the base?
E.
Okay, so yes, correct, it is a 0. Because anything to the power of 0 is a 1.
Yeah.
So right now for this, you have this negative, right?
Yep.
And also you have this I, and this I that can cancel, right?
Yes. No more. No more. But the negative is still there.
So can it become like this? But I want to tell you one identity of these. You have all those inverse sine plus whatever that
Yes.
can be half pi, right?
Yes. And let's say two types. Tangent and the cotangent, and the other one is the tangent and the tangent, but all are inverse. The tangent is inverse tangent x plus inverse tangent 1 over x, which equals half pi, and the other one is inverse tangent x plus inverse cotangent x equals half pi.
Okay, so these are two of it, okay?
Yep.
So here, this can be a negative 1 over square root 15. And here you can have your half pi minus inverse tangent,
Wait.
I just write.
Wait a second. That one is not 15 anyway. That one is 5. It's a 5.
So it can be like this, right?
Yeah.
So right now for this, when you times this, it is a constant, which you can put into the C, right?
Yes.
So next is this double negative, which becomes a
The double negative become a positive.
yes. Like this.
Okay.
But is this the same answer as just now? It is, right?
Yep.
These two. It's just that this can rationalize, right? So let me rationalize.
And what is that C prime?
Here's the C and here's the extra thing that I needed to put inside, but it's still a constant.
Okay. If you say so. And now the only difference is that the C prime, but we don't care.
Okay, so like this, is it all right? We
Yes.
got the two answers the same, right?
Yes, just a quick look.
All these, okay?
Yep.
Okay, so let's see. How much formulas or these rules have we used? Okay,
First one.
first, this is a factorize, right?
Yes. Second, rationalize. Third,
Wait, what about your partial fractions?
partial fraction. Fourth,
Third.
third is,
Okay, actually separation, right?
yes. Fourth is,
Okay, so after this step is, okay, that one doesn't. Okay, this formula for the ln, right?
yep.
After that, the fifth, which is a, what do you call it? And this ln, the minus that is actually a divide, right?
Yep.
Then, here the denominator rationalization, 6 already, right?
Yeah.
Okay, so then for this, what happens?
Then,
Okay, then the square that can come out, right?
yes.
7. Then after that, we here have the Euler's formula, right?
So then make a
8. So from here, okay, this step to the next. What happens?
8. And don't forget your ln.
Okay,
Trigonal
that
identity.
this here the trigonal identity, right?
So 9 already.
9, okay, and at last another rationalization,
So
which is
10.
actually about 10, right?
Yes.
So that is a lot, right?
Yep.
But this is actually just the simplest, right? This is just the simplest of these complex variables, right?
Okay.
Okay, so are you sure that you are clear of all of these?
Yes, and before we say goodbye, what you want to say?
Okay, so if you like our videos, don't forget to subscribe to our channel. Okay?
And next time we'll continue all over, but not everything.
We'll continue with these things, okay?
Yes.
Okay, so see you in the next lesson. Bye!